Hello and welcome to Science. This is the lesson for Thursday, December 17th. We are going to be in our science book today, so we're going to open up student software. We're going to scroll on down. We're going to come to Florida Science right here under the Florida Galaxy. Make sure you click Florida Science because if we click Florida Galaxy, nothing will happen. I'm going to open my book up. I'm in Unit 6, and today we are on page, let's see, what's it say? 302. So let's go on over there. Yesterday, we talked about chemical and physical changes. So, quick refresh. Chemical changes are things that permanently change something, like baking a cake. Physical changes do not permanently change it. It's just for the moment. It's bending or squishing, something like that. You can easily undo a physical change. Chemical changes, that's it. It's done. They're permanent. So today, we're going to talk about some chemical changes that can happen at home. So some chemical changes happen in science labs, but there are many that happen around your home. A lot of them happen in your kitchen. Sometimes they happen when we clean things. So I'm going to start over here with this From Yuck to Useful post, and it's about composting. So composting would be taking things like banana peels and orange peels and food scraps, and sometimes you put them in a composter, which is like a special thing to keep the smell inside because they're stinky. Or you can have a compost pile in your yard, and eventually it'll break down in a very smelly, long-winded way, and it will give you free fertilizer that'll be really good for your soil. So the breaking down or rotting away of the food scraps would be an example of a chemical change, because I can't get the apple back once it's rotted away. That's pretty gross. Now we're going to look at this category right here. It says, did a chemical change occur? So we have several clues that we're going to look for. Smell. Smell is a big one. Sometimes the smell is good. You walk in the house and you're like, cookies. A lot of times the smell is not so good. It says, as plants or animals decay, they release gases. Let's talk about this word decay for a moment here. So to decay is to rot. That is what happens to living things after they die. The bodies break down and they start to release gases. The gases are quite smelly, which is why the text says you may want to hold your nose because these gases stink. Color is another indication of a chemical change. So toasting bread, we talked about this on Wednesday. It's a physical change. Oh my gosh, I said physical. Chemical. Where'd my brain go? It is a chemical change because I cannot untoast the toast. Like once it's toast, that's it. It's done. It'll turn brown if it's good toast. It'll turn black if I burn it. There is nothing I can do to make the toast be bread again. Remember, chemical changes are pretty permanent. Physical changes can be undone. Chemical changes often release heat. Remember what I talked about with the tiny particles inside gases, solids, and liquids, and how heat and energy in science are synonymous, or they mean nearly the same thing? That is because the more things move, the warmer they get. If you take your hands and you rub your palms together slowly, it feels like skin, right? Nothing fancy happens. But if you start rubbing them very quickly, like as fast as you can rub your hands, eventually your hands start to get really hot. That is what they're talking about here. Heat and energy. So chemical changes also give off a substance. For example, things that burn, like birthday candles or burnt toast, often create smoke. So it's changed from one form into another. I can't turn something back Like if I burn some wood, I can't change it from smoke to wood. It's done. It's over. These clues aren't foolproof, however. There are always a few reactions that seem like they fit in both ways. So we'll think about it when we boil water. So the water bubbles and steam is released. But think about the water cycle. It goes from a liquid to a solid to a gas, or it goes like liquid gas, liquid gas, liquid gas, depending on where you're going. Because it goes and it rains, goes into a lake, it gets hot, it evaporates, it goes into a cloud, it rains, and it all goes over and over and over again. That's what they mean by a cycle. So that is a physical change. It's not a chemical one. When I boil water and it turns to steam, it's still water. If I boiled water and it turned into cranberry juice, that would be a physical change because it has permanently been altered. But if I'm just boiling water and I'm making steam, well, eventually that steam will become water again. It'll just take time. I'm going to scroll a little to the right and let's take a look at this other part of our page. So up top here we have these really pretty fireworks. And fireworks are an example of a, yep, you guessed it, chemical change. I mean, the title of our page is a little bit of a hint, but they're permanent. I cannot unexplode a firework. Once it's up in the air and it's going, that's it. It's going. So they are the result of powerful chemical changes. They are inside a shell. This is not like the shell of an egg or a shell that you find on a seashell on the seashore. This is a word for like a container that easily cracks. So you light a fuse. The fuse would be the thing in cartoons that stick out where they put the match and it makes something explode. The fuse sets off some gunpowder that is on fire and the shells explode. Yep, you heard that right. Fireworks have gunpowder in them. That's why they are so loud and that's why they're also very dangerous. We must be extremely careful with them. The explosion causes other chemicals to burn, which causes the sparkles that we see in the air. That is also why the fireworks will sometimes bring down ash. If you've ever been underneath a big firework display, sometimes little pieces of ash will come down from the sky. It's because something is on fire. Now, you have a 3-question exit ticket in Teams that's going to be asking for examples that come directly from this page. So for your exit ticket in Teams, which should be right underneath the post that has this video link, everything that you need is right here on the page. Let's talk about the pennies real quick, and then we're going to end our video here. So let's look at this dark penny. It says, is the dark coin dirty? Because we usually say like, oh, it's a dirty penny, and these are like the shiny, clean, new ones. Not really. So copper and silver would be the two main culprits. They interact with the air, and they start to change color. So the Statue of Liberty would be a great example. She's green. She used to be the color of a penny when she came over from France originally. The Statue of Liberty was a gift from France, and the Statue of Liberty was the color of a penny. Copper turns green when it oxidizes. That means it is exposed to the air, and that's why the Statue of Liberty is green. Silver also oxidizes, but it turns black instead of turning green. Alright guys, I'm going to wrap up our video here. Please make sure you do your exit ticket, and please make sure you refer back to the text.